Hi, I am going to discuss um, Module 4, and Module 4 is about composite figures. Okay, so this is about composite figures, and the objective of this video is for um, the learners to know about how to compute the area of composite figures. And then at the end of this module, you'll be able to learn or to understand the theorems, the properties, and the formula relating to composite figures. Okay. So you have different shapes in composite figures, but it's like one shape, but you can recognize a lot of shapes on it. So this is a trapezoid, and then this is a rectangle. Okay, so that's one figure, and this is a lot of triangles here, and then you can also see a hexagon shape. Okay, so another figure shows the like a square and the triangle, and down below is a semicircle and a rectangle, and on the other side it's a triangle with seems like a square or a small rectangle, and of course a triangle here, and another triangle. And on the other side you could see the rectangles, so three rectangles. So the perimeter of this composite figure, simply adding all the lengths of the sides. And for the area composition, our composite figures, you can have two ways on how to do it. So first you have the additive areas method. So here you can simply add all the check the shapes and then take their areas and then add up all the areas. And then you have the subtractive areas method. So in here you are going to get the area of the larger than the composite shape, and then get the small pieces which are excluded in that composite shape, then less the area. You reduce or subtract it to the composite area. So regardless of what method you use, you will often have to think carefully in the dimensions necessary for determining the area or perimeter. So let's do this. You see a composite figure here, a trapezoid and a rectangle. So the technique is for you to get the area of the trapezoid plus the area of the rectangle. So that will be your total area for that figure. And for the other figure here, if you wanted to do the subtractive areas method, simply get the shape like a rectangle there, covering the area which are not included in the composite shape, and then get the area of the bigger shape. So that's a rectangle, I guess, and then you subtract that to the small triangles on the edges or the corners, and that will be your area for that figure. So this is another way of getting the area. That is called the subtractive area method. And you have another problem here. So the problem says, yes, that's a combination of a trapezoid and the segment, right? And the condition here is that the segment, the parallel side of a trapezoid, since this is an isosceles trapezoid, so therefore the non-parallel sides are equal, and of course two of their bases are equal to. Okay, so here it's given that the angle on the side is 60 degrees. Okay, so you have to add all the two shapes together, and then you can get the area of this composite figure. Alright, so I have here uh, a solution which I did earlier, but I would like to draw a separate figure for you to be able to understand what I did in this drawing or in my solution. So let's start drawing that figure.
Alright, so given this figure which I did earlier, this is the trapezoid, which is an isosceles trapezoid, and this is your segment, which is also another shape. So the composite figure is composed of trapezoid, isosceles trapezoid, and the segment. Now, this is the center of your curve. Okay, so the line that is coming from this point to the curve is the radius. Now we want to know what is the measure of your radius, because in order for us to solve the segment, we need the formula of we need the information of radius. Okay, so let's look at this figure. If this is 60 degrees, this is given, right? This is given. And another figure which is given is this 3 feet. And of course, the 5 feet length, which is coming from this point going to the bottom. Okay. All right. So we have these different different kinds of shapes. We have the triangle, we have the trapezoid, and we have the segment. All right, so here, let's analyze the angle that we have here. This is, if this is 60 degrees, you can form a right triangle in this side in order to get this angle. So if this is 60 and it's a right triangle, so therefore this is 30 degrees. So that will be the same for the other side. Now, if this is 60 degrees, remember that when a radius intersects at a tangent, so there is a point here where the tangent line of the curve and the radius intersects to each other. And of course, this is 90 degrees. Okay, so this is 90 degrees. And the same thing as the other side, that's also 90 degrees. Now we want to know what is the theta. Now if this is 90 degrees, because this is the radius and this is the tangent of the line, the theta here is simply the difference of 90 degrees and 60 degrees, right? So this will be 30. Now, if this is 30, remember that we have this line also. This is another triangle or another perpendicular line. Okay, so this is 90 degrees, right? So this is also 90 degrees, because if you draw a line, straight line here, and this side here, it's 90, right? So if this is 30 and this is 90 degrees, so therefore this is 60 degrees.
So
Okay. If this is 90 degrees, as I've said, so this, therefore, this is 30 degrees because 60 plus 30 is 90. And if you can see, if this is 90 and this is 30 and this one is 60, so we can isolate this triangle and we can put it on this side. Okay, so we are isolating the triangle. No. Now, this is the radius. The radius is coming from the center of the curve going to the curve. And so, if this is 3 feet, kasi dito sa problem, it's 3 feet. Therefore, this is also 3. This is also 3 because this triangle is a triangle, equilateral triangle, and it has an equilateral. So the sides are the same and the angles are the same. Okay, now let's try to see how we can solve this problem. Okay, since we are trying to get the trapezoid and the segment, so we have to utilize the r. So 1/2 r squared is equals to pi r minus sine theta. So pi r should be in radian. Now, so here the area of a or a not semicircle, it's a segment, is equals to 1/2 r squared, open and close parenthesis, theta r, theta sub r, okay, and then sine theta minus, you subtract it to the sine theta. Now, to convert this angle, you have to use this conversion factor. 360 degrees is equals to 2 pi radian. All right, so with this analysis, we can conclude that the radius is equals to the length of the chord. So which is 3 feet. So kung 3 feet ito, 3 feet ito, at saka 3 feet din ito. Okay, since we are able to identify the R, we can now proceed with solving the uh, area. So 1/2, this is the area of the segment. 1/2 is equals to R squared, open and close, theta sub t minus sine theta. You have to convert this into radian. So 360 degrees is equals to 2 pi. So look here, 60 degrees times 2 pi over 360. Cancel, cancel, and then you got 60. All right, so your answer now here will be 120 over 360. So it means hindi pa na-cancel yung work. So this radian means that there's no unit, right? So unitless. Okay, so reducing this to the lowest term, we have pi 2 is equals to 1.07, 1, oh no, that 1.047. Okay, and the sine 60 degrees is equal to 0.866. So why do we need that? Because we have to get the area of a segment. Okay, so we have 1/2, r is 3, and then pi r minus sine theta, is segment is 0.8144. Okay, so after getting the area of the segment, we are now going to solve for the area of the trapezoid. Uh, in the trapezoid, we have this shape here wherein the base is given, which is equals to 3, as well as the edge. Now, edge here is the measure of the height of your trapezoid. Since it's not given, but we have this 5 given in the previous drawing. No, the 5 is actually coming from the bottom of that curve down or up to the 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 base of your trapezoid. Okay, so that's 5. So we can utilize that later. All right. So here, if we see this picture, okay, we have h, okay, equal to 5 minus y, right? So since this 5 is coming from this point, let me check. 5 is coming from this point. So therefore, if we consider only this point, so 5 is coming from this point up to this point. So we can get the y because if this is 5, actually dapat nandito yung center ng ating circle, no, nasa loob ng radius katulad nito. So nasa loob siya. So mali itong una nating ginawa dito. So pwede naman natin i-adjust pero pwede nating iakyat dito, no. We can move this going up, no. Okay. So kasi ang edge natin is height, no, of the trapezoid. So it has to come from the base. So ito yung center ng ating curve. So dito makikita natin ngayon ang ating triangle. So in order to get the y, where is that solution? So in order to get the y, you have to subtract 5 minus the r, right? This is the 5. Ito, minus yung radius. So, ang matira is, ito yung radius. So, meron pa siyang 2 dito, class. So, if this is the 5, okay, minus y, okay, or let's say minus h, okay, since this is 3, okay, ito 3 ito, kasi radius eh. Okay, mula dito sa point na to hanggang dito sa baba, yun yung ating 3 feet, no? 3 feet siya kasi yan ay ang ating radius. So, pwede natin 'to kunin and hingi tayo ng copy. Okay. So, 5 minus 3, no? Kunin natin ito. 5 minus 3, ito yung buong 5 mo, minus mo yung radius, ang matira dito ay 2. Okay? So, bale 2 na lang ito. So, ano yung y mo? So, ang y, dapat etong length na 'to, iso-solve natin. Puwede natin i-solve ito sa pamamagitan ng ating, um, triangle na right triangle. Okay, so since this is a right triangle and we have an 60 degrees and this is 3, right? This is 3 feet. So, makuha natin yung height nito. So, papaano ba pagkuha ng height? Asan na 'yun? Um, So, puwede din natin makuha yung ano, yung A, 'no? We can name this as hey A, okay? So, A is equals to sin theta, sin 60 degrees. Ito 'yan, oh, sin 60 degrees, equals to A times the R. So, A is equals to R sin 60 degrees. A is equals to 2.598. So, dito, you can see this is 2.598. Now, kung 2.598, yan, ang Y natin is, our Y is equals to 3 minus 2.598. Okay? So, Y is equals to um, 2.398. So, pwede natin sabihin Y is equals to, since this is the Y, 5 minus A minus 2. So, 5 minus 2.598 minus 2 is equals to the Y. Okay? So, that is 0.402. So, ibig sabihin, ito is 0.402. And now, we can solve for the h. So, h is equals to y, 5 minus 0.402. So, ito yun. So, h is equals to 4.598. Ito na yung height ng trapezoid. So, makuha natin ngayon yung ating area ng trapezoid, no? Pero bago yun, kunin muna natin yung x natin. So, x, pwede natin gamitin ang tangent, our x, by solving this triangle. Okay, let's go and solve this. So, we are going to change this to h, okay? So, this is h instead of A. So, this is equals to, ano ba yung h? 4.598. So, this is 4.598. 4.598 times tangent 60. 3. So, if we're going to draw the base again, no, kung i-drawing natin yung ating trapezoid, so ganito yan. So, ito ay 3, no? Ito ay 3. Ito naman ay i-add natin to 3 plus 2 times 7.964. So, 7.964, ita-times 2 natin plus yung 3, that is 18.928. So, this is 18.928. Okay. And of course, our height is 4.598. So, 4.958 yung ating height. We can now solve for the trapezoid. Kompleto na yung ating mga data, no? You can now solve for the trapezoid. So, area of the trapezoid is equal to FT. Okay, so that is the area. Now, hindi pa natatapos dyan yung ating problem kasi we are going to, dito na lang tayo, add, no? So, area of the trapezoid, sa total area of the composite figure Okay, so there you go. This is our final answer for number one for this problem. So you can check. You can do the solution again. Just you can pause the video and then you can also solve on your own. No, you don't need to just read and watch. You can also do and practice. Pause the video and then try to solve it on your own. That is how you learn in this video.